My name is José Pedro Santana Neto, and I'd like to talk about using Singularity on Piz Daint CSCS cluster with multi-GPUs. Basically, this presentation is a compilation of my experience with Hack 21. So first of all, just to refresh like a concept of Singularity, what is Singularity? Singularity is a container platform to run complex applications on HPC clusters in a simple, portable, and reproducible way. And what's the motivation to use Singularity? So, in my opinion, in my experience, Singularity provides a very simple way to create a self-contained environment for development and deploy complex HPC applications. Once the container is done, the deploy on HPC clusters is straightforward. Basically, when you have the container here working well, we can deploy without problems uh, in the several environments, several HPC environments here. And then that's very nice, pretty nice, because we can reproduce the results, we can manage well the package without touching in the clusters configurations and so on and so on. So I I do like to show my experience from source code to deploy on Piz Daint CSCS cluster with multi GPUs. In order to do that, we have 4 steps. First step, I needed to install Singularity locally on my computer. On my computer, I have Ubuntu 20, and then the second step is build a Singularity container. The third step is compile the code on the cluster, and the last step is run the container on the cluster with multi GPUs. So basically here we have a simple script to install Singularity locally. In my computer, for example, it was Ubuntu 20.10. Basically, we need to update the packets, and then we have to install these following packages here. Here we have the configurations of the system. For example, the architecture, the operational system, and the Go version. Basically, Singularity depends on the Go language, and then we need to install this by using this set of commands here. And then after that, we just need to install Singularity from the repository. And then in this presentation we cover the version 3.8.3, the Singularity version, but as you want you can change it. And then we just type Singularity version in order to check if the installation was proceeded well. And here we have the build step of Singularity container. In this step, I did it locally in my machine. Basically, we have here the file container.dev, which describes the container that I want to build. And then the command to build it is sudo singularity build container.cif and container.dev. Basically, the output will be this file container.cif. And inside of this container.cif, .dev file, we have here uh, the the steps to build the container. Here I'm getting an image from Ubuntu, and here you have some commands to install the package inside the container. We have this command to install, for example, git, vim, g++, gcc, make, cmake, and so on and so on. And then we need to install the MPI framework, which is the mpitch in this case. And this is an important point. We need to install the same MPI package that we have on the cluster, because in order to use Singularity with MPI, we need to communicate well. We need to bind the MPI versions, and then to that we need to get the exactly MPI version inside the container. That's why I'm installing here from source code the mpitch, and then after that we have the installation of HPC SDK from NVIDIA, and that's it. So once we have the container, after the build process, we have the file container.cif, and then we need to send from, for example, the local machine, from my machine to the cluster by using scp command, for example. And after that, on the cluster, we need to compile the code by using the container. Basically, we have the code outside the container, and then we just proceed with a compilation by using the container, and then the code will compile, and in the end we have the binary, but the binary concerns the configuration inside the container, not outside. So how could it be possible? So here you have the like a bash script that works with Piz Daint. So first of all, we need to install the modules on Piz Daint. After that, we just need to export a env variable to point to the container file here, and we can create like a workspace folder. After that, we just need to git clone a repository, something like that. We can modify the code inside this repository, this code, and then we need to create a bash script to compile the code. So this script will be you'll be in the process of running inside the container, not outside. So here we just need to create the script and assign a permission, and then after that we send a job in order to proceed with the compilation, but by using the container. We have here the Singularity exec command, and then we have the container, and then with exec command I need to put in the end the command that I want to run, and the command is the compile script that was created here. So it's worth pointing out that we use the bind directive to mount the pwd directory inside the container. In this way, we can capture all the changes made outside the container. Basically, the code is outside the container, and then we can modify the code and we can compile and run this code without like without problems. Like the code does not depend directly on the container. If the container crashes, we will not we will have the data yet. So after the compilation, we just need to, for example, here we have the executable path, the binary path here, and after that we just need to submit a job with, for example, here 2 GPUs, and then we are fine. And also, as we saw previously, it's worth pointing out that we use bind directive to mount the pwd directory inside the container. In this way, we will save all the output files on the host, not inside the container. So we can go further. We can create a submit underscore job.sh file and then send this to Islam by using sbatch command. And then here you have the configurations here, the number of nodes, the constraint, which is the GPU, the number of tasks, the threads per node. Here you have the output and error files that will be created, the account here, and you have the executable path of the binary. And also we have another interesting thing. We can use ANSYS profile from NVIDIA in order to collect metrics data for performance analysis and improvement. Basically, we just need to append some comments after containing path here, and then we are fine to collect data in order to profile the code, which is very interesting. And then in the end we have this profile here from the file that was generated by the ANSYS software, obtained from 2 GPUs computation submit by using the previous submit JavaScript. We can have the following profile here, which is very nice. And then we have like some problems here. We have like a lot of data transfer, host to device, the device to host, and then here we can analyze well what's happening. So about the final considerations, the HPC environment is very complex, and it's very common to find difficulties to compile and run applications natively. Singularity Containers provide a powerful and direct way to do that. In this presentation, we managed to run an application with multi-GPUs and collect metrics performance. This shows how we can use the container versatility in order to adapt the code for deep analysis. Unfortunately, CUDA-GDB was not tried, although there is no blockage for that. Okay, thank you very much.